Hi, my name is Adam Spencer and I'm currently completing a Bachelor of Exercise and Sports Science at the University of New England. I'm completing this presentation as part of the requirements for EXSC335, Motor Control and Human Development, coordinated by Dr. Dominic McNeil. The presentation that I've decided to do this on is the fourth practical, Fatigue and Performance.
So to begin, we're going to have a look at what fatigue is, what it's perceived as, and what fatigue actually is. So what is fatigue? Fatigue is defined as physical or mental weariness resulting from exertion. So it's an inability to continue exercise at the same intensity with a resulting deterioration in performance. Fatigue can result from a number of causes. It might include loss of muscle mass, deconditioning, nutritional deficiencies, oxygen delivery, anemia, to name a few. So there's two types of fatigue. The first one is central fatigue and the second is peripheral fatigue. So the first type of fatigue, central fatigue, is a form of fatigue associated with changes in the synaptic concentrations of neurotransmitters within the central nervous system. The central fatigue affects exercise performance and muscle functions, and it can't be explained by peripheral factors. Central fatigue can occur from prolonged exercise, and it's associated with neurochemical changes in the brain. It is primarily involving serotonin, noradrenaline, and dopamine. Central fatigue plays an important role in endurance sports. It also highlights the importance of proper nutrition prior, during, and post-exercise for endurance athletes. Another role of central fatigue is to prevent peripheral muscular injury. So the brain reduces the quantity of motor commands sent from the central nervous system in order to do this. So this is crucial in order for protecting homeostasis of the body and to keep it in a proper physiological state capable of full recovery. So the second type of fatigue is peripheral fatigue. Peripheral fatigue is associated with muscle exhaustion. Peripheral fatigue is basically an athlete's inability to maintain their expected level of exercise intensity. There are several factors that play part in peripheral fatigue, and it's often a combination of them that end up resulting in the fatigue. So we've got metabolite depletion. So ATP and CP levels will both decline with exercise, and as they deplete, muscle fatigue will set in as there's less energy to fuel the muscle contractions. We have metabolite accumulation. The accumulation of dihydrogen phosphate and lactic acid will cause muscle contractions to decrease their force. An increase in the phosphate levels in the muscle can also cause a decrease in the force of muscle contractions. Lactic acid accumulation will also decrease muscle power by displacing calcium ions that are essential to the process of the muscle contraction. And we also have any disturbances in homeostasis. So this can refer to anything from dehydration, training at altitude, training in high heat, or performing in high heat or very cold conditions. So we'll quickly just take a look at the signs and symptoms of fatigue. Some obvious signs and symptoms include the inability to maintain given exercise intensity. So you might notice that if someone's in a running race or rowing race or swimming, for example, that they might drop off their pace. You might notice that someone might be struggling to complete the last few reps in a strength workout. Some other signs and symptoms of fatigue might include sleepiness, headaches, sore or achy muscles, muscle weakness, or and impaired decision-making skills. That's why there's such a big push at the moment for driving cars under fatigue. So the aim of our experiment that we conducted was to examine the effects of physical fatigue on the performance of a motor skill. So we used a throwing task interspersed with fatiguing physical activity. So the equipment that we needed was an archery target. We used an A4 piece of paper placed on the ground about 3 meters away from the participants, some bean bags around about hand size, a fitness step, and a stopwatch. So the testing was completed with 31 participants. Each would do the trial 10 times under a fatigue condition and under a rest condition. The lab was completed in pairs. The participants would complete the conditions in a counterbalanced order. So one person would be doing the fatigue part of the testing first, and the other would be doing the rest, and vice versa. So in each condition, participants would complete 10 blocks of 10 trials. In order to induce fatigue, the participants had to do 130 seconds of high intensity step ups, followed by their 10 throws of the beanbag aimed at the target. A point would be given for hitting the target, and no points would be given for missing the target. So a maximum score of 10 points could be given each trial. So the results that we actually gained from the experiment didn't appear to show any significant detriment or improvement in performance between the fatigue trials versus the control group. Although the mean scores for the fatigue trials were slightly lower than the rest trials, they were not significantly different. What we did actually notice was that if there was anything to note, it would be that there was actually a small improvement as fatigue occurred. So as you can see from the graph, the mean scores improved slightly over the 10 trials, starting at around 5 and ending up at around 6. This may not actually have anything to do with fatigue, but it might have something to do with just the fact that the participants had practiced the tasks 10 times by the end. One thing that we did definitely notice was that as the participants became fatigued, they were unable to maintain their steps. We saw the average steps went from around 108 in the first trial to around 96 or 98 by trial 6, and 6, 7, 8, and 9, sorry. And then there was a spike again in trial 10, but this is probably just due to the participants' motivation, knowing that there was their last bout of the exercise. So in summary, we can't confirm or deny from this test that fatigue had an impact on the scores, even though on the graph it appears as though the fatigue scores were consistently slightly lower. They seem to be insignificantly slightly slower. It's important to also note that the students who completed the testing were all Bachelor of Exercise and Sport Science or Bachelor of Exercise Physiology students. So you could probably make an assumption that the students that completed it have some sort of a sporting background. And as the study from Ayoun and colleagues in 2008 found, skilled players are more likely to adjust their movement patterns and preserve the task requirements in terms of spatial accuracy under fatigue by changing their movement patterns, whereas less skilled players are less likely to do so, and so they might suffer from fatigue more so. So it would be interesting to recomplete this test with a general population group doing the test.
In summary, we know there's currently a large amount of research on fatigue and its effects on performance. It's a very important subject, especially in the sports science world, as it can have such detrimental effects on performance. There seems to be more research on the peripheral mechanisms of fatigue than those related to the central nervous system. It's important to remember when programming and training athletes that fatigue is going to be more noticeable in novice athletes than elite ones. It's also important that we remember that fatigue is not preventable. However, with proper nutrition, hydration, and the right mindset going into a race or a workout or whatever it might be, that we can help delay the onset of fatigue and help you reach the desired outcomes. Thank you very much for listening to my presentation.